we had seen that rational numbers were defined as P by Q, where P is the numerator, Q is the denominator, and the denominator could not be 0. That is P by Q, where Q cannot be 0, is how I defined rational numbers. We'd also seen that P by Q can be interpreted as P times 1 by Q. That is a multiple of unit fraction. So this fraction or this rational number can be seen as P times or a multiple of unit fraction. Now with rational numbers coming into the picture, we had to define operations of rational numbers too. So how do we add, subtract, multiply, divide these rational numbers? That was the question. So let us see how we add rational numbers. We had seen that 1 by 4 added 2 times, 1 by 4 plus 1 by 4. 1 by 4 plus 1 by 4 gives me 2 by 4. Similarly, if I add another 1 by 4 to this 2 by 4, I get 3 by 4. So what is happening is that the denominator is not changing and the numerator is getting added. 1 plus 1, 2, denominator is not changing. Look at here. Denominator is again not changing and numerators are being added. 2 plus 1, 3. So what we concluded is that if there will be two rational numbers which would have the same denominator, Q is the denominator in both the cases, then the denominator remains the same and the numerators get added. So P plus N by Q. Similarly, if I want to subtract now, let's say I have this length 3 by 4 and I subtract 1 by 4 from it. So I am left with 2 by 4. So 3 by 4 minus 1 by 4 gives me 2 by 4. Or I can see it as the denominator is being the same, remains the same, numerator is being subtracted. So if the denominator is the same, again what I need to do is just subtract the numerators. That's how I can subtract two rational numbers. So we have seen that if the denominator is same, we can add and subtract easily. The denominator remains the same, add or subtract the numerators. Now what if the denominators are different? What do I do then? How do I add or subtract two rational numbers when the denominator is different? In such a case, I know how to add and subtract when the denominator is the same. So what I'll do is, I'll change this in such a way that the denominators become the same. That is my aim. I would change it in such a way that my denominators become the same. Once the denominators are the same, I know how to add and subtract. So let's say I have this 1 by 2 plus 3 by 5. How do I add this? Now the denominators are different. What I'll do is, I'll take LCM of the denominators and make them the same. Let's see how. LCM of 2 and 5 is 10. So I'll make the denominators equal to the LCM, which is 10. How do I do that? I have 1 by 2. To make the denominator 10, I'll have to multiply by 5. So if I multiply the denominator by 5, I'll have to multiply the numerator also by 5. So I get this, the other fraction. Let's look at the other fraction now, which is 3 by 5. Again, now to make the denominator 10, which is the LCM, I'll have to multiply this by 2. If I multiply the denominator, I'll have to multiply the numerator also to keep it the same. So I get, this gives me 1 by 2 becomes 1 5s are 5, by 5 2s are 10, and 3 by 3 into 2 by 5 into 2 becomes 3 2s are 6, by 5 2s are 10. So instead of writing these two fractions, now I can write these two fractions, because all I have done is multiplied the numerator and denominator by the same number. That is not changing the fraction. So instead of this, I can write 5 by 10 plus 3 by 5 is equal to 6 by 10. Now how do I add these? Denominator is the same. And I need to just add the numerators, which is 5 plus 6, which gives me 11. So one way to add rational numbers with different denominators is you take the LCM, make the denominators the same and add. Or what you can do is, let's say these are the two rational numbers with different denominators. What you can do is you can just find a multiple of both q and n. That would be qn. It is n times q, a multiple of q. Or you can say it is q times n, a multiple of n. So it is a multiple, a common multiple of both q and n, that is qn. Now make the denominators qn equal to the multiple which you found, the common multiple which you found. Make the denominators the same, which would be equal to qn. To make the denominator qn, what I'll do is, for p by q, I would multiply, to make denominator qn, I would multiply both the numerator and the denominator by n. Similarly, for m by n, I would multiply both the numerator and the denominator by q, because I want to make it qn. So now what do I get? In this case, I get pn by qn. In this case, I would get mq by nq. So qn is same as nq, multiplication is commutative. So the denominator is the same now. All I need to do is add the numerators. So pq plus minus mn, that is either you add or subtract, would be pn, add the numerators, plus mq, the common denominator, which is qn, or you can write it as nq. So this is the general form. So if you have two rational numbers where the denominator is not the same, just multiply the denominators, that becomes the denominator. For numerator, cross multiply pn plus mq. Even for subtraction, it would be pn minus mq. So the denominators can be multiplied. Further, for the numerator, cross multiply and then add or subtract. So now can you solve this question, which is 5 by 6 minus 3 by 8. Two rational numbers, denominators are different. One way is take LCM. What is the second way? Just multiply them together. Let me first do it by the shortcut way, which is 5 by 6 minus 3 by 8. Shortcut way is just multiply the denominators. 6 8s are 48. That becomes here. Cross multiply and subtract. 5 8s are 40 minus 6 3s are 18. So this gives me 40 minus 18, 22 by 48. Which again, after dividing both numerator and denominator by 2, I can get 11 by 24. Now let's look at the other way. Taking LCM. So if I take LCM of 6 and 8, 6 is 2 into 3. 8 is 2 into 2 into 2. So LCM becomes, taking this only once, 2 into 3 into 2 into 2, which is 24. 3 2 is 6, 6 2 is 12, 12 2 is 24. So you get LCM as 24. Now you have to make the denominators equal to the LCM, which is 24. To make 6 equals to 24, I multiply both by 4. 6 into 4, 24. 5 into 4, 20. To make 8 again as 24, what I'll do is multiply it by 3. 8 into 3 is 24. Again, the numerator also has to be multiplied. So what I get is 20 by 24 minus 3 3s are 9 by 8 3s are 24, which is again equal to 11 by 24. So you can see that answer does not change whether you take LCM first, proceed, make the denominators equal to the LCM, or you simply multiply the two, cross multiply and subtract. So either ways the answer would not change. So that's how you can add or subtract two rational numbers which have the same denominator or different denominators.